In the last video, we learned about the simplify and rule. And just means multiply when we're dealing with independent events. So in this video, we're going to look at some examples of this. So first of all, what is the probability of tossing 3 coins and getting heads, heads, heads? Well, first of all, notice that the 3 coins are independent. Whatever happens to one coin is going to have no influence on another coin. So we have 3 independent events. Probability is 1/2 for getting heads in one case, 1/2, 1/2. And so the 3 1/2s just get multiplied for a probability of 1/8. 1/8 is the probability of tossing 3 heads. Another question. What is the probability of rolling 2 6-sided die and getting snake eyes? That's a 1 on each dice, so snake eyes would look something like this. Well, again, the 2 die don't influence each other, so these are independent events also. The probability of getting a 1 on one 6-sided die is 1/6, so 1/6 on one, 1/6 on the other. They're independent, so that means and means multiply. Multiply them and we get 1/36, the probability of rolling snake eyes when you roll 2 dice. 3 cards are selected from a full deck each time with replacement. What is the probability of selecting 3 spades in a row? So again, let's make sure that we're perfectly clear on this idea of with replacement. What that means is I shuffle the deck, I pull a card out, I look at it, then I put that card back in the deck, shuffle it again, so that the second card I pick is being picked from a full shuffled deck. There are 52 cards when I make the second pick. Now I look at that second card. I record it, I put it back into the deck, I shuffle again. So now when I pick the third choice, I'm also picking from a full deck of 52 cards, a full shuffled deck. So all 3 cards are picked from exactly the same conditions, a full shuffled 52 card deck. That's what's going on with replacement. Well, of course, in a modern deck, there are 4 suits. There are hearts, diamonds, clubs, and spades, and those are evenly divided. So the chance of picking 1 spade is 1/4. And then on the second pick, it's also 1/4. Then on the third pick, it's also 1/4, because we're selecting with replacement, because each time the choice is made from the same initial conditions, the events are independent. The choices are independent. That's always true with replacement. That means we can just multiply. We get 1/64, the probability of selecting 3 spades in a row. Finally, we get this algebraic equation. We don't even know what the events are, but we're told that they're independent. Sometimes the problem will just tell you A and B are independent. Probability of A is 0.6, probability of B is 0.8. What does the probability of A or B mean? Okay, well, this is a bit of a curveball. We were talking about an and rule, and here we have an or rule. What's going on here? Well, let's think about this. This is the general or rule. And incidentally, if the events are independent, that means that they cannot be mutually exclusive. If events are mutually exclusive, they're definitely having an effect on one another, because if one happens, it prevents the other from happening. So that is definitely a very different case from independent. If they're independent, they're not mutually exclusive. We need to use the generalized and rule. So let's think about this. We know the probability of A, we know the probability of B. Probability of A and B, well, we can get that because the events are independent. We can get this by multiplying. That would be 0.6 times 0.8. The probability of A and B would be the probability of A times the probability of B. 0.6 times 0.8 is 0.48. So now we know all 3 terms. So now we can say we have 0.6 plus 0.8 minus 0.48. So this is 1.4 minus 0.48, and this winds up being 0.92, which is the probability of A or B.